In 1989, a group of scientists was assembled to decode the human genome under the direction of Dr. James Watson.
One of Watson's big motivations here was to try to recruit the best and brightest from many different disciplines, biology, but also physics, chemistry, engineering, because all of those would have to get together if this was going to work.
Many of the biologists, and I love them dearly, of course, were dragged into it kicking or screaming in the beginning because they failed to see the tremendous value that such an enterprise would provide the field.
The talent turned out to be all over the world, so you have to basically make it possible for those bright minds to get engaged where they are. They're not going to all move to join this effort.
Genomics has fundamentally changed the way we do science. It brought the notion of team science and collaboration to biology.
Curious thing about collaboration, it's also intensely competitive. Each person wants to achieve something personal. They want to make their hit, on the problem, but then immediately they want to share it with the other, and the other learns immediately. And so you ratchet each other up.
From the beginning of the Genome Project, there was a fairly strong sense of enthusiasm in the public sector, the private, and academia.
We had lots of support from Republicans, partly because Newt Gingrich was interested in science, and I knew it. There's no partisan difference in everybody wanting to live as long as they can.
I think there's a lesson there. It isn't a big monolithic project. It was a big challenge, but it brought people together. And I think that's what we have to do in the future.
When the Human Genome Project was started, it's important to note the technology of sequencing was not developed yet. So it's, in a sense, a project that was launched with a wing and a prayer.
We couldn't sequence it at that time. The machines were nothing like fast enough. There were no machines even. Sequencing was done by hand.
I thought we might have to do it brute force, and I was quietly prepared to use the old-fashioned technology just because it was so important to get it done.
There are a lot of things, that would make life easier that just hadn't been invented yet.
It'd be a 100-year project like monks working to copy a book at best.
Bit by bit, we got into more and more large-scale sequencing. But the sequencing is enormously important because it provides the possibility of searching by computer.
When I showed up at Washington University one day with a computer terminal kind of under my arm, people looked at it and said, "What are you going to do with that?" This is a genetics department.
Genomes were supposed to be too complex to be able to reassemble them in the computer.
Without computers, we simply would be dead in the water.
Computers and genomics were made for each other. Genetic information is digital. It's like binary code. It just happens to use 4 digits instead of 2. It is amazingly accurate, and that's what biology gets from digital information.
The Human Genome Project contributed a cultural change about data sharing, because the Genome Project was about sharing data almost immediately. And while it seems obvious now, it wasn't obvious then. That required significant effort.
I think I'm quite lucky as a scientist because I grew up always sharing data. The community around me, the genomics community, the worm and fly communities as well. It's just a default that you're going to share everything. You're going to share code. You're going to share everything by publishing, but you're going to share it before publishing. You're going to share half-cooked ideas. And in fact, this is a wonderful thing. It's liberating.
It would have been virtually criminal to try to hoard discoveries that meant the difference in life and death in people.
This is information which we'll be using for centuries. The sooner we get it and everybody has access to it who wants it, the faster we can move in terms of understanding how life works and how disease occurs.
Patients invest a certain degree of fear about genetics? Who's going to find this out? How will it be used against me?
A lot of the ethical and social considerations that we're struggling with today really have historical roots in the early 1900s in the United States, where we had many states that had laws that allowed us to forcibly sterilize people and prevent them from having children based on whether we as a society felt that they were genetically fit.
So at the beginning of the Human Genome Project, we got it right of bringing in the social scientists, the ethicists, the lawyers, and we now have helped to provide a whole generation of scientists that are focusing on the ethical and social issues of genomics.
The sequencing of the human genome was a monumental achievement. Decades of work, thousands of scientists, billions of dollars, and we get this first roadmap for what makes up the human genome. It's an incredibly exciting moment. At the same time, it's just the beginning of what's really a much longer voyage.
And let's again be audacious, but let's not be unrealistic about what's possible.
I think the next 10 years are going to see some exciting developments in genomics, particularly those where we start to use genomic information as part of routine medical care. And that'll be applied to dealing with diseases like cancer, hypertension, diabetes, and Alzheimer's disease.
I dream of the day when every young mother brings a young girl or young boy home from the hospital with a little gene card, and they say, this is the way you should prepare this child's health care. It's exhilarating.